This question gives us a function right here and says for this function, there's four important intervals. A and C are critical numbers, and B is a place where it's not defined. Okay, let's take this function. So here we have the function 8x plus 5x to the minus 1. Let's take the derivative of it. That's how we're going to find critical numbers, right? It's the derivative. So the 1 power comes down, going to be 8, and then minus 1, so the x is gone. Minus 5, that's because the minus 1 comes down. Subtract 1 from the power, it's minus 2. So there's the derivative. Now, we need to set that equal to 0 or infinity. Basically, either one, anything that'll make it 0 or infinity. And I can tell you right now, um, well, let's solve it. How about I don't tell you right now? Yeah, let's solve it. Move the 8 to the other side. We get minus 5x to the minus 2 is minus 8. We divide by minus 5 on both sides. And I meant to change the color on that. Divide by minus 5 on both sides. Boom. So we get x to the minus 2 is 8 fifths. What do we do with that? Well, remember that means 1 over x to the positive 2. Remember negative powers jump to the bottom, then become positive. Okay, so how do we solve that? Diagonal, diagonal. 1 times 5 is 8 times x squared. Okay, so then divide both sides by 8. Boom. X squared is 5/8. Last step. We're going to root it. When you put a roof on the house, don't forget up and down the ladder, plus or minus. So there we go. X is plus or minus root of 5/8. Now, one other thing. Right here, x is denominator. You can see it from the beginning, had a negative power. So that means x equals 0 is going to make it infinity, right? Now, they said not defined. That's another way you can say the same thing. From the very beginning, when you have a negative power, that means that x is in the denominator. And that means, remember, 0 in the denominator is not defined. Do you know that? Let me make sure you're clear. If we have 0 on the top, like 0 over 3, that's just 0. Why? Well, think about what a fraction means. 6 over 3 is 2. Why? Because a fraction means bottom into top. 3 goes into 6 2 times. So 3 goes into 0 0 times, but then 0 in the bottom, yeah, the bottom, like 4 over 0. That's going to be infinity. Why? Because 0, again, bottom into top, 0 goes into 4 forever. So remember, 0 underneath is infinity. We also call it undefined because it's not a number, but it's really infinity. It's just not a number, so it's not defined as a number. So anyway, when they say not defined, that's going to be at 0. Why? Because we have a negative power in the original function. So x equals 0 is going to make infinity. Same thing with the derivative. You just look at the derivative and go, it's got a negative power. So what's going to make an infinity? 0. So either way, x equals 0 is our b in the middle. And we got plus or minus root of 5/8. You hit the buttons on the calculator. So this is minus root of 5/8. This is 0. This is plus root of 5/8. Here we go. There's the decimal version. Now they want to know where are those increasing and decreasing. So to figure that out, going to need to do a little number line action. So I'll come on down here and I'll put those 3 spots on the number line. So we've got this one, break it into, wait, 3 spots, 3 spots. Hold on. Make that a little more like right in the middle and then right over there. Okay, so we got the x values. That's negative point. So this is x is negative 0.79. X is 0. X is positive 0.79, right? Those were the decimal versions of those. They want to know where it's increased, decreased. They're calling this one A, B, C. So great. Okay. So we got to find out increase, decrease. What's going to tell us that? F prime positive is increasing. F prime negative is decreasing, right? First derivative, slope, up or down. So that means I got to check on the first derivative. What was the first derivative again? Right here. 8 minus 5x to the minus 2. First derivative is 8 minus 5x to the minus 2. I got to pick some checkpoints. So I'm going to go, okay, I'm going to check over here. This would be something like -1. Something that's in the first interval. Something like this would be negative zero point 0.5 in that interval. Something over here is positive zero point 0.5. Check on that. And then over here, 1. Oops, come on. Check on x is 1. So I'm going to check. So I'm going to grab -1, plug it into that function. So I've got that already on Desmos. Put in the -1, got 3. Here it is. So f prime is +3. That means function's going up, isn't it? Increasing. Now I'm going to plug in -0.5. Let's go do that. -0.5. -0.5. And I get 6.75. Positive. Positive 6 point. So it's still going up. It's increasing still. Positive. Let's check the next section. I'm going to plug in +0.5. Wait, oh, did I do the wrong one? Did I do? Oh, no, I did right. Okay, now +0.5. I don't think it's going to matter. +0.5 is still positive. 6.75. Is this right? Are we getting the right answers? No, this should have been decreasing. What am I doing wrong? It's supposed to be 8 minus 5x minus 2. 8 minus 5x minus 2. Um, 8 minus 5x minus 2. Let me double check. Am I doing something wrong? Oh, that's a positive part. That should be negative. There's my mistake. Just kidding. All right, let's go back. First, let's try it again. First one should have been -1, plug in -1. Went a little too quick there. You got to be careful. Just showing you how easy it is to mess up. No, I'm not. I'm messing up. But so the first one was right. Second one, -0.5. Let's change that to -0.5 now. It's -12. So that should be -12. So this should be -12 and it's decreasing. So it's decreasing. Okay. Now the next one, I'm going to put in +0.5 and it's still -12. So it's still decreasing, further decreasing. And last, I'm going to plug in x is 1. So it's 1, 3, +3. So then it increases in that last section. All right, so there we go. So we've got increase, decrease, decrease, increase in those sections. Increase, decrease, decrease, increase. And so there we go. Be careful with those functions. Be more careful than I was plugging into Desmos. There we go.